All right, CNT125, we're continuing on Chapter 7. We're on the section on virtual architecture or hypervisors. So one of the first things we talk about virtualization is hypervisors. Virtualization is just that. It's a virtual version of something instead of the physical. So I might have a physical computer, but I might have two virtual machines installed on top of it. That would be virtualization. So the host is the actual physical computer, my desktop, if you will, for an example. My physical desktop is the host, and my guest would be each virtual machine that's sitting on top of that physical host. And the hypervisor is what's making that possible. In the example in our lab room, we're running Windows 10 on our desktops. That'd be the host physical computer. On there, we have VMware Workstation installed. That's the hypervisor. And in the VMware Workstation, we have a virtual machine installed. That would be the guest. When we get to lab, you're going to launch VMware Workstation and you're going to build your own virtual machine in there using the Linux operating system. So we'll have a physical Windows desktop computer with the VMware Workstation hypervisor, and then inside of that will be our guest Linux virtual machine, just to kind of put all those pieces together for you. So this would be our desktop in the lab room, running Windows 10. The hypervisor would be our VMware Workstation, and then in there would be the virtual machines we're adding, in our case, a Linux virtual machine. There are two types of hypervisors, a type 1 and type 2. Well, I just got done talking to you through a type 2. We actually have the host operating system, in our case Windows 10, and our hypervisor sitting on top of that, VMware Player. Okay, VMware Workstation, VMware Player, that sort of thing. In our lab room, that is what we would use. At home, that's probably what you would use. You might have a Windows desktop, you install VMware Workstation, and you install a Linux virtual machine in there to take a certain class. Okay. Once upon a time, I had a laptop and I had Ubuntu Linux on. I installed VirtualBox and put, in that case, I think it was a Windows XP as my virtual machine on the Linux host. I had flipped it around, but the same idea applies. The type 1 is the kind of thing that would typically be on a server. I might actually have my server and I load on, before anything else, I literally load on something like ESXi by VMware or Hyper-V from Microsoft. That gets loaded on, and then that is the OS on the server, and I load my virtual machines on top of that. This has the advantage of there's less overhead. Windows 10 or Windows 11 has a lot of overhead. This has minimal overhead in comparison. So my server can do more server functions instead of dealing with host functions, if you will. So if I take a look at the difference here, here's that type 1 that I just got done mentioning. I would have the server, I load the type 1 hypervisor on, VMware ESXi kind of thing, and then I load my virtual machines on top. Meanwhile, our lab stations, we have Windows 10, then we have VMware, then we have our virtual machine. So this is using up some of the processing that Windows 10, if you will. So this is a lot less efficient with our processing, our storage, our RAM, etc. Okay, so a lot of times your servers are running in this environment with the type 1. Here's some of the big players right now. VMware, we have VirtualBox, we have Zen Server, KVM, Microsoft Hyper-V. There has been a shift in the environment recently. Broadcom bought VMware, so there's going to be some shift in kind of like the pecking order of these, but VMware is still pretty high on the list, still has a pretty large market share. So we're still going to be using VMware in our lab room that's probably mostly what you're going to end up working without on the job, if you will. Okay, so my virtual machine, my hypervisor, if you will, here, I can customize the hardware that is getting used. I can adjust the amount of memory processing that I'm using. I can adjust the size of the storage on my device, on my virtual machine as well. Each virtual machine has its own NIC, virtual NIC, VNIC. And that can interact with my network in different ways, depending on how I set that VNIC on my hypervisor. The maximum number of VNICs on a virtual machine depends on the limits imposed by that hypervisor. I think once upon a time, VirtualBox had a limit of up to 8 virtual NICs per VM. So it's really up to the hypervisor on how many virtual NICs you can have. So I could have a couple virtual machines. Each one of this has a virtual NIC on there to identify that device, that virtual machine. With my, and this is what I'm looking at here, network adapter settings. Okay. When that is selected, your VNIC is selected, I can actually, the hypervisor creates a connection between the VM and the host. This is typically through something like a bridge or a switch, if you will. So I have my physical NIC here, and inside the hypervisor is this virtual switch that all the virtual machines connect to. Okay, so that's kind of what's going on in the software of this hypervisor, just to give you an idea. That vSwitch or virtual switch operates the data link layer, passes frames between the nodes, and allows these virtual machines to communicate with VMs or other nodes on the LAN. Okay, so that's what we have here, and I can even have, if I have tuned virtual NICs, I can have this host. Actually, let me say it this way: if I have a host here and a host here, these virtual machines here can communicate through this switch, this physical NIC through the router, this through this switch to this one, as if these would be 4 different nodes on the network, all virtually. Now, my VNIC can be set a couple different ways: bridge, NAT, or host only, and these will affect how this virtual machine operates. So the first one, bridge mode. Most of the time in our lab room, this is the setting we're going to use. This actually accesses the physical network using the host machine's NIC. It gets its own IP, its own gateway, so forth. So as far as the network's concerned, it's just another node on the network. So here is the actual physical host. There's this NIC in the virtual switch. Each of these virtual machines are going to receive their own IP. 192.168.1.132, 192.168.1.33. The host machine has 192.168.1.131. So as far as the network's concerned, there are 3 different nodes here: 131, 132, 133. And as far as the network's concerned, there's 3 different devices here connected to the network. So bridge mode is what we tend to use in our lab room. That makes this device appear on the network as if it's another device on the network. In my virtual machine settings, I would select my NIC setting, my VNIC setting right here as bridged and so forth. And I might need to go through the process of making sure it's attached to the right adapter, because you might have a wired and a wireless. You might want to make sure it's attached to the correct network adapter on your machine. The next setting is NAT mode. NAT mode, now the hypervisor actually NATs the connection to the virtual machines. So it actually protects it. So the hypervisor has its own, if you will, DHCP server in here. It'll NAT this 1.131 into its own private IP scheme, in this case a 10, and it has its own DHCP server to hand out addresses to this guy, 1.129, 1.128. So these devices are hidden behind this physical NIC, this physical device here. So the network does not see them back there. They're there. I can communicate on the network, but it does not see them as they're their own node, if you will. So this is shielding this behind. You might do this to protect these devices and actually route traffic to and from them, but protect them behind this one. In my virtual machine setting, this is a VirtualBox here. You'd select your NAT mode as opposed to bridged mode. The last mode, and we're not really going to use this in our lab room, this is a host-only mode. This would be kind of for developmental purposes. I'm building up this virtual machine, I'm testing it, that sort of thing. And this is now going to be like not attached to the network, if you will. So this thing is not attached to the network. I might work with these 2 virtual machines here. Maybe I'm making this a server, this is a client, and I'm working on the communication between them, or a certain type of new server for a certain type of client that we're managing the network. And I might use these and do all the testing and work on them before releasing it onto the network. Okay, and again, here I would pick my host only mode. Here was bridged, here's NAT, there's host only. My virtualization, I do have some pros and cons with virtualization. I don't have to have as much physical equipment. So in some case, I get some cost savings from that. And because I don't have so much physical equipment, I have some energy savings. I'm not powering as much. I have simple backups, recovery, replication between these pretty easy. I'm using my resources well, because maybe in the old days I might have 3 or 4 servers that are running, barely half capacity. Well, I could have combined those. Okay, that's kind of what this is doing. I'm only building up and using kind of what I need. The disadvantages are it is compromised performance. If I don't set these virtual machines up well, one is robbing from the process and the other one needs. I do have increased complexity and licensing costs. I'm not going to get away from, it's going to be free now. I'm still going to have to pay licensing costs. And I do have a single point of failure, because if that physical server dies, all the virtual machines on top are dead in the water, if you will. So there is some pros and cons to virtualization. However, this is very common for a lot of places to put maybe 2 or 3 servers on one physical box. Or a vendor might have a server that they're renting out that they have 3 or 4 virtual machines on for different server functions for different clients. Okay? When we come back, we'll continue on.